So we will start with the basic introduction to machine learning. What is machine learning? It is a field of computer science. It's focused on the building system that we can learn some patterns from the data, or the algorithm can learn some data patterns or structures from the data. Here we make a comparison between traditional programming and machine learning. In traditional programming, a human writes the rules and the logic step by step. For example, if we want a program and to detect spam emails, we might manually code the rule like if the email contains something like buy something, pay the money, this might be a spam email. And well, in machine learning, that's not necessary to create these rules, and you feed the computer many examples of spam and non-spam emails. You let the machine or the algorithm to learn something from these emails and to create the pattern, so that the machine or the machine learning can create the rule for you. And after that, you can use these computer-made rules to screen these spam emails. Okay, these days you might heard a lot about buzzwords in this community like machine learning, like deep learning, like AI. So you might be confused about this word. What is AI and deep learning? And in a further step, what is the relationship between them? Here, let us clarify this. We use this figure. Let's say AI. AI is a large scope. The exact definition may vary, but it generally refers to a technique that enables computers to mimic human intelligence, thinking, solving problems, making decisions, and also reasoning some issues. The main aim of AI is to create a system that can perform tasks as we humans do, recognizing images, understanding language, and also play games like AlphaGo. If we shrink the size, then we come to machine learning. Machine learning is a subset of artificial intelligence. It focuses on the developing algorithms and the models that enable computers to learn some patterns or some structures from the data, and also then make decisions or predictions. So we can say that machine learning is one of the primary way to achieve AI, and has various techniques like supervised learning, unsupervised learning, reinforcement learning. We'll come these topics later. To further narrow down this area, we come to deep learning. So deep learning is a specific subset of machine learning. In deep learning, it uses neural network to learn some these complex patterns in large data sets, in images, in audios, in videos. And this neural network are designed to mimic the structure and the function of human brain. In this workshop, we are not going to talk too much about deep learning, but we do provide some tutorials and code examples so you can get the first expression about the neural network, how to construct the neural network, and how to train this neural network so that this neural network or this model can predict something from this data set. Okay, we know about this AI, machine learning, and deep learning. Why we use machine learning right now? This question is quite straightforward. A primary thing is that machine learning is transforming the way we solve the problems in the real world, which is different to that before. Previously, we use classical programming, right, to solve the problems. We have the data, we know the rule, then we get the answer using classical programming, like the perform addition operations of two large vectors. But however, in many real-world scenarios, such as medical diagnosis and natural language processing, the relationship between input and output is somewhat too complex, and we don't know what is the rule. We don't know what is the rule. Maybe something, but the machine learning can uncover some hidden patterns and make the predictions for us. Another advantage of machine learning is ability to adapt and also to improve this model over time. For example, like we predict the stock price. Today, we can use the data from yesterday, and the next week, we can use the data from this week. So this model can always generate new predictions for us. The third is that machine learning can automate the complex tasks we are depending on human expertise in the previous or in classical computing. Because of these advantages issues, machine learning is shining in varied areas from healthcare, financing, transportation, education, and also entertainment. We can say that machine learning is now an internal driving force for this industry innovation. All right, machine learning is promising and we can use it for sure, but wait for a sec. We should clarify some problems that can be solved using machine learning. Some problems can be or can't be solved using machine learning, or some problems can be but shouldn't be solved using machine learning. The first one may be straightforward. We can use machine learning to solve lots of problems, real-world problems, healthcare, financing. Here's the list. We can imagine that machine learning is almost everywhere in our daily life and in our work. The second is about the problem can't be solved with machine learning. Machine learning is powerful, but it's not magic. It's a tool to find something in the data and tell us about the new prediction. Below are the key categories of problems that can be solved, like problems with insufficient or poor quality data. We know that machine learning will need lots of data for this. So if we have quite limited data, it's quite difficult to make the prediction. And the second is anything related to thinking and reasoning that cannot be solved using machine learning. At least right now, it cannot be solved. Here I mean that we get the machine to get these results, and the model cannot think, or the model just follow the instructions from us. The model doesn't know what is right and what is wrong. The third category is the problems can be solved, but shouldn't be solved using machine learning. Currently there are many problems as ethical, practical, or societal concerns, or some privacy-sensitive applications like analyze personal data. We are not allowed to use machine learning to handle this. All right, this is the general introduction about this machine learning. We know what is machine learning and its relationship between machine learning, intelligence, and deep learning, and examples of some problems that can be, cannot be, or can be but shouldn't be solved using machine learning. Yes, in this episode, we talk the fundamentals of machine learning, the type of machine learning workflow, and machine learning libraries. Type of machine learning, usually the machine learning have three, we said that it has three main categories depending on the type of data and the learning approach. The first is supervised learning, is trained model using labeled data, meaning that each input comes in and get a responding correct output from the training. There are two main types of supervised machine learning, classification and regression. Like the classification means we want to classify the penguins into different groups. Regression means that we predict weather conditions, house price, stock price. We will cover these two tasks tomorrow morning. Unsupervised learning is it deals with unlabeled data and it aims to find some patterns or structures in the data. The two main tasks is about one is clustering and the other is dimensionality reduction, and we will cover these two topics in the third day. Reinforcement learning is something different. It's the goal-oriented learning approach where the agent will interact with the environment and receiving reward and penalties based on these actions. So in this learning, there are two items. One is agent, one is environment. And there are two roles, reward and penalty. The models want to use trial and error way to learn which action the agent should take so as to maximize some behavior. Like you train the dog to catch up the ball from somewhere, or the AlphaGo I mentioned before. AlphaGo is one of the most famous real-world example. Reinforcement learning, it applies to play the board game Go. And actually, besides these main categories, there are also some subtypes. For example, semi-supervised learning, self-supervised learning, and transfer learning. Semi-supervised learning, it bridges the gap between supervised and unsupervised, which means that this learning will use a small amount of labeled data together with a large amount of unlabeled data. I will talk about the importance of labeled data because this for some data, in some data site we have this labeled data, or humans should label the data. It's the cost. It's costly and it takes time. That with a large amount of data is not labeled. Transfer learning involves the application from pre-trained model to a new and related task. This is to reuse this model, fine-tune the model, the hyperparameters for this model, and apply it to another machine learning task. For example, you know how to play guitar, and if you are going to learn ukulele, it's quite easier because some skills transfer, like reading music and finger coordinations. Okay, we should know the general workflow of machine learning. So what is the workflow? Workflow is a structured approach for developing, for training, and deploying machine learning models. It involves several key phases or key steps right here, including data collection, data preprocessing, model training, evaluation, and finally deployment. Except for the final step about the deployment, we will cover all the other topics in the following episode about data collection, data analysis, training the model, and also evaluate the model's performance. This is a graphic representation of machine learning workflow. Let's start to describe the step by step. First, we start a machine learning project. We should have some business understanding. What is the real world problem? What we're going to solve using this machine learning to predict some house price, classify some classify some penguins, some figures like cat, dog, grouping some data. We have an example right here. Suppose you want to apply for the loan from, say, Handelsbanken in Sweden. You want to buy an apartment. There are two scenarios. Case one, you talk with the loan officer, said, "Hi, I want to apply for 2 million Swedish krona." This is case one. Case two is you talk with the same loan officer. "Hi, I want to apply for the loan, but can you check my credit and let me know how much I can apply for?" These two scenarios, you will get a totally different feedback from the loan officer. The first one is you said you want to apply for 2 million and you will get answers yes or no. This is the classification task. I mean, it classified in two parts, yes or no. For the second one, it's about a regression task, because you said how much I can apply for the loan, and you will get exact number. For example, 1.8 million, 1.5 million. This is a regression task. Once we know this problem, and we decided to use machine learning to solve this problem, we move a step further to collect lots of data from a variety of resources, for example, database, sensors, APIs, web scraping, survey, and social media. Once we have this enough data, we can move further about data processing, because these collect data are too raw. There are lots of inconsistencies, a lot of missing values, outliers. When we handle this data to polish data to a structured data format, so that we can use machine learning to learn something from this data set. Besides this data processing, we have other steps for the data analysis or visualization. And this will give us if the data is good or not so good. The main purpose is to prepare data in a structured format so that the model can effectively learn the hidden patterns in the dataset. We should say that this is the most important step right here, as the quality of the data will have a significant effect on the model performance. All right, data is ready. Let's train the model. But before that, we should do some manual tasks like to choose the algorithm. For classification task, you should choose the right classifier. For the regression task, you should choose the regressor. And also, we are going to have data splitting. Data splitting involves two steps. We will see this in the tutorial. We will extract the features and the labels from the dataset. We will split the data into training and the testing set. And we will have this feature scaling. And we will cover all these facts in the tutorial. Then, ready the training. I will train the model with different algorithms. We choose the right model and we tune the hyperparameters, cross-validation, and definitely we can test multiple models to see which one is the best. Yeah, and this step involves matrices and techniques to qualify how well the model can make the predictions. Actually, different tasks, we have different evaluation matrices. And for this classification and the regression task, we will see what kind of matrix we're going to use for the evaluation. If the model is okay or is good, then we come to the final stage about the deployment. That is an integration of the model trained right here into a production environment, for example, API or cloud platform, so that clients can use it. If the model is not so good, usually there are two general procedures to take. First is to use the same dataset from here, and we train another model. We will see that each model has its pawn as the coins, so we should pick up the right one for our specific task. The second is that we continue to use the same model, but we try to further preprocess the data and use this same model for further training. And actually, we have the third one, which means we used updated data set and train another model. But this is too complicated. You will run out of control because you changed the two variables right here. Yes, this is the general workflow to train a model using machine learning algorithms. The detailed steps may vary depending on the specific dataset and the specific task they're going to run. But this is the general way we perform a machine learning task and also in this project. Okay, let's come to see some quite well-known libraries about machine learning. Here are some quite well-known libraries about this for this machine learning. We have scikit-learn. It's well known for its simplicity. It's ideal for the beginners. Keras is another one. It's a high-level neural network library. It was originally developed as an independent library, but now it is integrated as part of TensorFlow. TensorFlow and PyTorch, they are more advanced and now widely used for machine learning and, we should say, in deep learning applications. Besides this, there are some other libraries focusing on specific tasks. For example, right here I have Hugging Face Transformers, it provides tools specifically for natural language processing and the fast AI for deep learning, and also JAX for the high performance numerical computing. And also here I list the best features of these representative libraries and also the key strengths of these libraries right. Yes, this is the fundamentals of machine learning. We cover the representative types of machine learning, include supervised learning, unsupervised, semi-supervised, and also reinforcement learning and the other subtypes. And we talk about the general workflow of the machine learning project, including the identification of these problems, if machine learning is appropriate to solve this problem, and if yes, we can on for this data collection, data preprocessing, data processing, and we train the model and evaluate the model's performance. If everything is good, then we come to the final phase of deployment. But usually we will take a large amount of time to fine tune the model hyperparameters so that we can get a better performance of this model before the final deployment. We also mentioned some representative machine learning libraries, including scikit-learn, Keras, TensorFlow, and PyTorch. Yes, this is the second episode right here. All right, let's move on to talk about the data. Finally, we come to the data. For the training, either for this machine learning or deep learning models, we need data. We need lots of data. So before they talk about the big data, let's bring this question for the short discussion. And how large is the data you're working right now? And are you experiencing some critical issues, performance bottlenecks when you're trying to analyze it? Yes, hope that you megabyte, gigabyte, terabyte. Okay, cool. Then you will get a different experience about the performance bottleneck because it depends the size of the data and you have to use specific packages to accelerate the data analysis if you want to get this some result in a short time. Okay, I would like to move on to talk about this. So you can leave your comments right there. How to solve these bottlenecks. What kind of specific package you're going to use, what's the kind of programming tools, or you use another tool for this data analysis, not only Python, like Julia, like R, like MATLAB. Okay, I will move on. So talk about the big data. Big data refers to the extremely data for large and complex data sets that are too big to handle using traditional tools. If we say big data, it usually have described the four V's. For example, variety and volume. Volume is quite large, big data. And also the variety means that this data comes from different types like text, image, audios, videos, and so on. And also the velocity, the speed of change, that's the streaming data. And the last one is veracity, which means the trustworthiness of this data, the quality of this data. It means that if we should use this data for some applications, we should trust this data or not so much. So data are collected from varied sources like experimental measurement, sensors, financial transactions, or social media like LinkedIn. So the emergence of big data is changing the way we are thinking, we're trying to solve in many fields like business, healthcare, climate science, and genomics. With all these lots of data set we have, we can make predictions. We can get some hidden patterns from this data, and then we can make new predictions. That we can get some insight from this data. So for machine learning, data is crucial because models need the big data, need lots of data, and also diverse data to train the complex patterns and the data set before the making predictions, or we can say making accurate predictions. So without enough data or without high quality data, even the best algorithm can not work well. That's to say, data is the essentially the backbone of machine learning or the deep learning and also even for the AI. So in this episode, we will explore some scientific data, the type of data, how it is stored, and how it is organized. We will look at different data format. There are points and cores like CSV and HTML5 and others. And we also would like to mention about data structure, which is commonly used in machine learning and deep learning, like scalar, vector, matrix, and also tensor. So scientific data. Here we just focus on the scientific data. So scientific data is any kind of information that scientists collect, observe, measure, and create during research and experiment. We can think about this scientific data in two ways: type of data and also form of data. Type of scientific data, it is focusing on the nature of category of data it contains. But generally from the data size, from small to large, we can have different content like this. The smallest is the basic unit is bit and byte. A bit is the smallest piece of computer storage. It can be only 1 or 0. So 8 bits make 1 byte. So with 1 byte, we can represent 256. 250 different values. So by grouping data, computers can store many kinds of data. For example, numerical data. Numerical data such as integers, floating point numbers include this. Integers can be exactly stored in computers. It's fine as long as you have enough byte in your computer. Floating point number is a little bit tricky because many decimals cannot be stored exactly in binary. So in machine learning, when we care about this, you will often hear about the half precision, single precision, double precision, and they describe how many bits or bytes a computer need to store these floating point numbers. So a floating point number is, if it says double precision, it means that the computer will need 64 bits or 8 bytes to store this number. It has high accuracy and the large range, but when during the training, it is slow and will use a lot of memory and the computer resources. So the floating point number with half precision means the computer will use 16 bits or 2 bytes to store this number. It is less accurate, but during the training, it will use less memory and it will get a faster training during this machine learning. Single precision is a good balance between half and double precisions and between speed and also accuracy. I should say that this single precision is the standard format and used in most scientific machine learning and deep learning frameworks like PyTorch, like TensorFlow. I also would like to highlight that mixed precision is always available in machine learning and deep learning applications because modern models, I mean, if we say the large language model, especially in the field that has computer vision and the natural language processing, we will have billions of parameters that require lots of amounts of computer resources for the computation. Training of these models usually use single precision. This will be quite slow and memory intensive. Therefore, combining half precision and the single precision is a practical way. I mean, with single precision to have some critical calculation and half precision to have most operations, so that we can achieve better balance between accuracy and also speed. Well, we take an example. Everyone knows about the GPT, right? Do you know how many parameters for the GPT, let's say 3? It was released 5 years ago. If we say GPT-3 and 175B. Yes, ChatGPT has 155 billion parameters. Okay, it's a lot, right? Let's take a simple calculation about this. If we, for these parameters, if we store these parameters in single precision, I mean 32 bytes a bit per parameter, it will take approximately 600, 700 million gigabyte. But this is just for parameters. If you're familiar with machine learning, you know that during this training, not only the parameters, but also the activation functions and also the gradient, we take lots of memory. That's why mixed precision is essential, especially for the large language model. It will, as these parameters, and will cover lots of memory during the training. Okay, highlight that PyTorch and TensorFlow, both of them support the mixed precision. So if you're going to use PyTorch and TensorFlow, you can to see how to use this mixed precisions for the training. And if you save your memory and also to speed up the training. Okay, beyond the numerical data, we can have text data and also the metadata right here. So we will see later that during the training, we need to transform text or other data, images, audios to numerical values because the computer only works with numbers. The computer doesn't know what is text, what is images, what is audios, or videos. So we have to transform everything to numbers. For all these data, either numerical, categorical, text, or the others, they stored in different forms. So we will talk about the form of scientific data. Form is described how the data is organized and stored in the computer. It's about the shape or format of this data. Here I list some representative formats of tabular data structure, textual data structure, images, videos, and the graph network. Tabular data structure, this is widely used in our work, machine learning work. It covers some representative things like scalar. This is for 0-dimensional. This is just a single number. For vectors, it will 1D. It can be a row or a column in this tabular data structure. Matrix is a 2D format in this tabular structure because we have rows, we have columns, and the tensor is the data form larger than 3D. It represents a high dimensional block of numbers. Text data store lots of information as strings of characters. They can be letters, numbers, or symbols. If we're going to use text data or category data during this machine learning task, we have to transform this to numbers. In the tutorial later, we will see how can we use encoding techniques. For example, OHE, label encoding, or get-to-do-means in pandas to encode this category data to numbers. So images, videos, and audios, they are have different format. Image is stored in visual data as pixel grids. If in this in the machine learning in this workshop, I'm not to cover this handled images, but it's really the basic thing. If we are going to have this classification task, you want to classify the images depending on the object in this image, like cats, dogs, birds, and cars, planes, different categories. This is nothing about the category, but this is not covered right here. We during this workshop we only handle the tabular data, and also some others about growth and graph and the networks, and also the form of scientific data. Yeah, I'm not good talk too much about this. So we are now familiar with the type, the forms of data. Let's move on to another topic. It's about data storage format. So to see how the data is stored in the computer, what kind of form is stored right there. There are many ways to store the data. Actually, I should say that no single format works best for everything. So you should pick up the one to fit your data needs. In machine learning task, we work with tabular data, which is usually stored in CSV file. CSV is a comma separated values file. It is easy to read and also to share, but this only works for a small amount of data. If you have a large data set, you might need to do high performance storage format like HDF5. This is for the high performance storage format for large data set. Below, I provided a table to get an overview of data storage format, Pickle, CSV, Feather, and H5, and the JSON Excel. You can see the points and the coins of all these data storage format. Which one is going to use depending on the project you're going to conduct, and also the size of the data and also the format of the data. If it's tabular data, it's recommended to use the CSV. If the images and the videos, you can take the other format to store this data. Okay. As we are working on this machine learning and the deep learning thing, so we only care about the data structures for machine learning and deep learning applications. So machine learning and deep learning models can only with numbers. We know about this, and because the computer can figure out the numbers, not other categories, categorical variables, textual images, and all those. Everything should be numbers. So this means that we first need to collect enough numerical data before the training. And if the data come from other format like images, videos, so we need to transform this this data to numbers, usually arrays or tables. So numerical data, numerical arrays is the way we are going to use. They are the basic building blocks we need for machine learning or say deep learning. So numerical array is a collection of numbers arranged in a specific structure that one can perform the mathematical operations, like the scalars. This is just one number. Vector, just 1D. This is 1D object. It can be a column in the data in the tabular data or one row. 2D is for the matrix, and the 3D is matrix, but for the high level, high dimensional space. Yeah. Python has many libraries working with numerical data like NumPy, PyTorch, TensorFlow, and Dask. Dask is a Python library designed to handle large data sets for parallel computing so that it can speed up the data analysis and also the operations. In machine learning and deep learning, the data is somewhat different. We call it tensor. So what is the tensor? Tensor is basic, is always is a way to store and work with multi-dimensional data. We can say that tensor is a generalization of scalars, vectors, matrices, and also high-dimensional data. In other words, every numerical thing in machine learning and deep learning is handled by a tensor. Tensor is everything. That is the idea where the name TensorFlow comes from. It means It literally means tensors are flowing. But why tensors is used in machine learning and deep learning? So the main thing is that the tensors can handle any number of dimensions. Everything is named a tensor. It can handle the fast computation for the frameworks. Frameworks like TensorFlow and PyTorch, they can optimize the tensor operations for GPU and even for TPU. TPU means for tensor processing unit. It's mainly designed for the handle the tensors. And then about the consistency, images, text, and other data format, it can be easily converted to tensors. So everything we call it tensor. And tensor they used across machine learning and deep learning frameworks, consistent. So that if you want to use another framework like Keras, like JAX, everything tensor, you can easily transfer the data from PyTorch to JAX to the others. So that make it easier to build and train the model. Yes, and we are now coming to the end of this episode. And before the exercises, I can have a short summary about this. We provide the key characters of big data. It's full width, it's volume, relative velocity, and veracity. So high quality and large data set are essential for this machine learning and deep learning tasks. Scientific data has different forms, including numerical, textile, and multimedia formats. And these are the different forms. So we should transform these forms to numerical ones before the training the model in machine learning and in deep learning. Scientific data are stored in various formats, like CSV, we're quantified by CSV, and HD5, depending on to meet the different property requirement for the storage. Tensor is important. It's the generalization of numerical data in machine learning and also in deep learning. Tensors allow models to efficiently handle complex multidimensional data, as images and audios. Yes, we have exercises right here using Jupyter Notebook. If you click this Jupyter Notebook, you can come to this right here. I can guide you to show a little bit this Jupyter Notebook, but later you can run the code exercises in this Jupyter Notebook. First, the introduction, what is tensor? Here, give quite a image about this. One, a scalar for 0D, row vector, column vector for 1D, matrix for 2D, and the tensor for the data more than 3D, 3D, 4D, 5D, like this. So tensor and the array is quite similar. They all can handle the data, but the tensor is the advantage is tensor that its operations performed on the GPU part. I mean, GPU has lots of optimizations to handle the tensor operation. Tensor can keep track of graph and computations when that created them based on the advantages of tensor. Let's see the examples right here, how to create tensors. We can from Python object. Oh, actually I can handle this right here. If you come to the GitHub repo, you can download or to your personal computer, come to the content Jupyter Notebook directory, and you can see we have several Jupyter Notebook right there. Come to the third one, it's about the tensor. This is about the tensor and how to create this tensor. How to create tensor is really straightforward. Here I use PyTorch, for example, and if you use TensorFlow, it's almost the same. If you change Torch to TF, TensorFlow or TF, but pay more attention that for some commands, some method, it's not a direct one-to-one. Yes, let's run this. It is, check the tensor version. Installed it is 2.3.1. Exactly, you can see how to generate these tensors. This tensor are generated on the CPU part, right? It's not on the GPU. If you have GPU, you are going to use GPU for this training, so you have to take one step further to transfer the data from CPU to GPU. But if you don't have GPU, it's fine. You can use just the CPU for this training in the machine learning task. From Python object, you can see how to create the tensors, and you can also from NumPy object. You can use NumPy to generate arrays and using different and to generate tensors like this. You can see this is the tensor and this is the type. Int 32, this is the type. This is the size for these integers to be stored in this computer. And from NumPy, yes, you can see how it works. If you're going to use TensorFlow, it's also straightforward. From generate the tensors from Python list, from NumPy array, it takes minutes to start this TensorFlow. How come it's so slow? Yes, it comes. You see, the shape, we can get, this is the tensor. The shape is it's 4, means it's the 1 by 4. And the type is int 32. This is the type of the integer stored in the computer. All right, from the functions, you can see how to create tensors, and this is for the TensorFlow. I'm not going to run all these samples, and I will leave this to you later. So you can play with code to run this Jupyter notebook. We can generate random tensors with different dimensions. I see. This is a tensor. It's a 3 by 3, and this is another one 3 by 3, and 4 by 5. You can generate any tensors with any shapes and forms. Tensors properties, there are 3 mains. We check the shape of the tensor, the dimension and the number of dimension of this tensor, and also the type of the tensor, D type. And it can be integers, it can be float numbers. For float numbers, it can be single precision, double precision, or if you can say half precision. I can run this. Yes, I generated the tensor. It's integers, int 64, or int 64, and float. After transformation, I can transfer it to, no, this is another one. I generate from the integers, but I ask the type to be float numbers. You can see the default for this float number is float 32. This is single precision. This type of conversion, you can convert from integers to float numbers and the float numbers to integers. Specify the specific type for these numbers. Operations, there are multiple operations about indexing. How can you define the index for a specific number in this matrix or in this tensor? I can combine multiple tensors into one, and also we can split the tensors into multiple sub tensor. We can also call it a tensor. And yeah, but there are built-in mathematical functions to perform pointwise operations, reduction operation, comparison, linear algebra operations, and spectral other mathematics operations. And for basic mathematics, add, sub, multi, div, neg, and you can get the different operations on these tensors. See, basic arithmetical calculation. You can see reduction functions. If you use the built-in functions, then you can get this result quite fast, because both PyTorch and TensorFlow have optimized these functions so that it can achieve the best performance. Comparison, linear algebra. I will scroll down and you can play with code later. The last thing I would like to mention that if you don't have a GPU, or if you have a GPU, even you have GPU in the computer, you might get an error on this one. But if you use Google Colab, it's fine. You can run this code example right here. You can generate the tensor on CPU and transfer this tensor from CPU to GPU and back. You can see when I generate this tensor, I should specify the device. If the CPU and then CPU, if the CUDA, that is for GPU. And morning tensor between CPU and GPU, this is the critical step. If we're going to use GPU for this machine learning task or even deep learning tasks, for everything will be handled using CPU. But after this task, we should fetch the data from GPU to CPU. So there will be communication between CPU and GPU. Okay, if you don't have GPU, I think the last section should be fine. We are not going to use GPU for the machine learning tasks, so it's fine. Just leave it there. All right. It is time for us to play with the code. Let's have the exercise for 20 minutes. And after that, we'll have a coffee break. All right, let's move on to the next episode about data preparation for machine learning. In the second episode, we addressed that data preparation and the processing often takes a large amount of time in the machine learning workflow, sometimes even more than the time for the training. Such a process include data cleaning, transforming, and organizing raw data into structured data, because we want to get a structured data format before the training process. So in this episode, we're going to have an overview of data preparation. We employ the Penguins dataset as an example, and to provide some hands-on exercises. This tutorial will cover handling missing values, outliers, and encoding category variables, because all these aspects will be used in tomorrow's tutorial about regression and classification. Before we come to the Penguins dataset, let's talk about what is the data preparation. Yes, data preparation refers to the process to cleaning the data and transform the raw data. It can be numericals, it can be images, to the structured format. Structured format means everything is numerical. This is a very important step because the good data helps models perform better. Key steps of this process include collect data from multiple sources and handle missing values, a mutation, or just to totally remove these missing values. Detecting and treating outliers. We should know what is the outlier, and then we will take a step further to handle how to handle these outliers. We can remove these outliers, or we can just mutate something to keep it there. Encode the categories variables. We will come for the penguins. We will see there are category variables like species, like sex, like island. We will see how to encode these category variables to numbers. Normalizing and scaling features. This is important especially for some distance-based algorithms. They will calculate the distance between these features, and so if value is larger, it has more important to affect the training process than the smaller numbers. Then feature selection and feature engineering. This is large scope about the data preparation, but we can mention something about this. So data collection, let's go through this step by step about the data collection. We start about this because we can collect the data from various sources. This is really project dependent, and if you work in the experiment something, you can collect this data from the experimental measurement, from modeling, and work in the human social science. So maybe you can collect some data from the social media, LinkedIn, X, something. This is too really project dependent, so I'm not going to cover too much about this. But for this workshop, we will use public dataset instead. Here I list some popular dataset, including tabulated data. Oh, right here. Yes, tabulated data, for example, Aries, the penguins, Titanic, Boston housing, or sometimes California housing, wind extra. This date site will provide usually provide the CSV file, so you can get lots of features and properties in this data site. Image data site, for example, MIST and image night. So they for the MIST, I think it contains the images for 18,000, 18 or 80,000. I can't remember the exact one. Maybe a smaller one that contains 8,000 images, mainly for quite convenient for the classification task. There are lots of images like a cat, dog, plane, cars. So you can follow this for to perform a classification task. ImageNet is a large data set. It contains millions of images with labels. So this is usually used for the deep learning task, for the training, either for the classification or for the other tasks. There are also some text dataset for sentiment analysis. For example, this one and sentiment 140. And here also some audio and video dataset. If you are going to work on this deep learning tasks, this measurement, this dataset are useful for you because you will get the direct, you can get the data from this dataset. This workshop, we are going to use this one, the penguins dataset. We can use this one to perform lots of tasks, classification, regression, clustering, and dimensionality reduction. You see, this is very useful and quite user-friendly for the beginners. It's quite a limited data, but we can get insight from this training using this data set. So we're going to handle a lot of aspects about the missing values using this data. Let's see how to download this. We come to this practical part. Okay, the penguins data set. Either use this one for during the teaching, the same to the web page, but you can just directly run the code right here. So this is the penguins dataset. It's a popular dataset for the beginners to learn the machine learning and deep learning. You might get familiar with this one before, but it's a popular one, and it contains information about the 3 penguin species, Adelaide, Gentle, and Chinstrop, and their physical measurement like body mass, like flip length, and bill length and bill depth. Let's see how to load this dataset. Before we need to import some common packages like NumPy, Pandas, Matplotlib, the Seaborn. We're going to use these packages for the data analysis. Then we load the penguins dataset. Here I load this from the Seaborn because Seaborn provided the resume right there. If you have a CSV file in your computer, you can copy paste everything right here. If you use Google Colab, you can even download this dataset from the website. URL is provided here. So depending on which you are going to use, you can use different method to load this dataset. We see what is available in this dataset. We have 7 columns. We have 3 columns right here. 3 is numerical features, bill length, bill depth, flip length, and body mass. These numbers. And we have 3 columns for categorical features, species, island, and sex. can see some data are missing. It's called none. So we will see how to handle these missing values. We can get a general information about this site. Let's say run this penguins.info. We see okay, these are the columns, space name of these columns, and how many non counts right there. This is object, means categorical, floats, numbers, and the general description of this data set. For these numerical values, for example, body mass and the Felipe length, we can have a statistical description about this. How many columns right there? Okay, the mean value for each column, the standard deviation, the last 5 rows right here, which is the quartile. We can come to later about handle when we handle these missing values, we use this quartile method. But here is just know about this, and I will give this detailed description later. So we see these numbers right here, but this it is difficult to figure what's the meaning of these the values, and we want to see more. So we want to visualize this data set, because the visualization will get a better impression about this data and where the distributions of this physical measurement like bill length and body mass. Then we can plot we can pair using the pair plot from Seaborn to see the distribution of 3 species. If we say first we see the distribution of sex, male and female. Okay, the blue for male and the orange for female. Even for these 4 features, bill length and body mass, etc., it is difficult to separate. I mean, from males to this group, or for females to this group, though that this sex feature may be not a good one if we can have a separation depending from the physical measurement right here. Okay, let's come to another one about island. If it's island, maybe we can see some separations of one species to the others. Okay, for some feature combinations like this one, I think this is the flip length or bill depth. We can see this orange. This is the Bisco. The penguins from Bisco seems to have clear separation from the other 2 species. But this is the main thing. If we consider to use the flip length and the bill length, we can have kind of good separation of these penguins from the data set, even if there are some data points scattered or have overlap there, but it should be okay. And not only this one, if you see this is the same, also this one, the bill length with body mass, you can also get a good impression that if we're going to use this combination, we can have kind of separation of these penguins into the different groups. Okay, we come to the next one. We visualize this according to a species. I have 3 species right here: elderly, chain strips, and gentle. We can see how, if we use these species as a label, we see, can we separate this? For gentle, it's quite clear. Flip length or bill length, we can see we have clear separation. That's the boundary right here. So for gentle, it's quite easy. We can classify gentle into one group. But for elderly and chain strip, it might be not so easy. I can see that it definitely not possible from here. But if we say from this combination, like bill depth and bill length, seems kind of okay. We can have something, but the boundary between these species is not so clear. So you can see that more samples, more penguins right here. So it might be not easy to have a clear separation. But tomorrow we will see if we want to draw a line to separate these penguins into different groups, which one will give us the better performance. I mean, which algorithm will give us the better performance. Now we are quite familiar with the space. We know the basic information of these penguins. This side, let's move on to handle missing values. What is missing values right here? These data sites has more than 344, I think, samples right here, but it's too long. We cannot handle this. Just for the clarification, we use the first 5 samples and the last 5 samples and combine to a new one called the test. Okay, see, we highlight the row with missing values. You can see for this one, the third number 3 and number 3339, we have missing values for these 2 penguins. One is elderly, one is gentle. Let's see how to handle these missing values. This is quite a small data set. It has 10 samples right here. We take 2 steps to handle the missing values, one for numerical and the other for categorical features. But let's first handle the numerical data. There are several ways we can handle the missing numerical values. The straightforward way is that we just remove this data. We remove all these missing values, the whole row from the data set. But this can be kind of waste of data and reduce your sample size if you have a quite a small data set and you want to use all the data for the training. So a better approach is immutation, to replace the missing values with reasonable estimate. And usually we immutate with the known with mean or median values of that feature. Step 1, we will see how can we immutate with mean and median immutation. We take the body mass, for example. We calculate the mean and the median values of the body mass and then concatenate. We first calculate. Okay, the mean value for the body mass is 4431. The median is okay, quite close. Well, these two variables will be used later. You see, and then we concatenate these two as to get a new one. I mean, to get a new column. All right, we concatenate two columns. One is B body mass gram, and the value is immutated with mean value. The other one is mediated with median value. You can see we have 2 columns here. We for this value is still missing because we did not immutate this value in place. We create a new 2 separate columns to store this data right there. Then we visualize after this immutation, we see how the changes of this feature. Make a plot like this. This the green is the body mass, the original data with missing values. And if we mutate with mean, it's orange one, is median, it is this blue one. It changed a little bit, but it is reasonable because in this small data set, we only have 10 samples. I mean, any changes in these 10 samples will have a kind of impact on the distribution of this feature. We will have exercises later to see if we not only the body mass feature, if we want to immutate the others like flip length, like build depth, how to do. If we want to imitate all these features, how to do, I will leave this to you. You can do this one by one, or you can find a feasible way to imitate all missing values, all missing numerical values in the data set. Yes, and the next method, Postman method, is to imitate with the end of distribution. What is end of distribution? This is if we have a distribution right here, imitated with end values right here. The calculation is kind of straightforward. You see the equation, mean plus 3 times STD means we can get all these values can be get from the using the penguin test dataset and also the pandas. Mean method get mean and .std make a standard deviation. And then we know what is the value for the EOD, end of distance. Okay, this is 373, 158. Well, this value is kind of weird, right? Because if you see here, the distribution, oh, the distribution of body mass is always distributed around 3,000 to 6,000. But if we say 7,000 is far beyond this scope right here. But is this value usable or not usable? We don't know. Maybe we can consider as an outlier. But here, just as the example to see how can we imitate the missing values with the EOD value. Okay, concatenate another column. Let's see. We have the third one. This is the mean, the median. This is EOD. The missing values is mutated with replaced with this EOD value. This kind of abnormal, right? And then we see the distribution with this. Even in this data set, we have 10 examples, 10 samples right here, but we can see that these two values really change the shape of the distribution far beyond here, because these two new values is at 7,300 something right here. I correspond to this plot. Okay, but we know that these two values are really abnormal, though we are not going to take steps. So during the data processing of your data set, pay more attention that if you can use mean and median, it's the better way. And if you're going to EOD, make sure that such immutation will not change the shape of the distribution or not too much of the distribution. This is the handling missing numerical values. Let's move on to the categorical data. Again, we see what is missing. Okay, two value for the sex categorical is missing here. Number 3 and number 339. So we handle missing values a little bit here. We handle the missing categorical data is a little bit different. Definitely, a quick way is to replace everything with the most common, just the mode. What is the mode? Mode is the most variable in this column. In this column, for this sex, for example, sex, we have 5 female penguins and 3 male penguins. So female is the mode, and we will replace the missing values with female. Okay, straightforward. Let's see. Okay, before the mutation, we have 5 female penguins and 3 male penguins right here. And we see the mode of this sex feature mode is female, correct? And we move on. Before mode imitation, we have 5 females, 2 now, and 3 males. But after the imitation, we see the result. Okay, we have 7 females and 2 male penguins right here. And if we see the distribution before and after the mutation, let's see how it looks. Okay, before means we have 5 female and 3 male penguins, and after the mutation we have 7. Definitely for this small data set, any changes you will have a clear visualization right here. But if you have a large data set after the mutation, if you see the distribution, if it does not change too much, it should be fine. I can use this method to imitate the penguins with missing values. Yes, and a possible way is also that you can imitate these missing values with a constant value. For example, with unknown, with missing. And here we just imitate with missing. We see what it looks like. Okay, just replace the none with missing, because for some algorithms, they will not handle missing or unknown. If it is known, this is not applicable. If it's missing, it's okay. We can use this rule, I mean, except this sex feature right here. To keep the data consistent in all the machine learning tasks from tomorrow and the day after tomorrow, we are going to keep it quite simple. We just drop all these rows with missing values. Okay, here's the distribution. We'll see how it looks like. Okay, one family, one missing. So we are going to drop all these missing values, and we just to use the rows with 4 values right there, either numerical values, either numerical features and categorical features. After handling missing values, let's move on to shift to treat outliers. But before that, we need to know what is an outlier. And previously we calculated the EOD, it is here. We want to know if the calculated EOD value is outlier or not. Let's print this, okay. This is the EOD, and this is also the EOD value for these 2 penguins. But first step, how to define an outlier? What are the outliers? And these are the values that stand outside the scope for regular values for one feature. Minutes ago, I adopted the EOD immutation, and for the penguins, the regular value for the body mass is from 3,000 to 6,000, but the EOD value is 7,300, yeah, 100 something. So this is really outside the scope for regular body mass values. So this can be outlier, but we should have clear definition why these values are outliers. Yes, let's play this. Okay, we have 2 points here. These might be outliers, but for chain strip, there are also 2 data points outside the scope. These 2 might be not considered as outlier because they are some kind of still within the scope for penguins, even not for chain strip, but for the whole penguin data set. It's kind of reasonable. We first use interquartile method with interquartile range, the IQR method, to clarify if these 2 abnormal values right here are outliers. Let's see the basic description of this person, of this Bayes length right here and the body mass. Minutes ago, we mentioned about these 5 properties, means mean, 25, 50, 75, and max. These are the quartiles. What's the quartile? A quartile is a way to divide the data set into 4 equal parts. I mean, 4 equal parts. After sorting this data from the smallest to the largest, we can have 4 groups, 4 parts, or say. 4 parts means that we have 5 values from 0, 25, 50, 75, and 100. That is the quartile. So mean means the smallest value in this column. Max means the largest value in this quartile. And we follow this rule to see the 25 is this value, and the 50 in this value, and the 75 in this value. 25 means quartile, the first quartile means, it's noted as Q1. That's the first quartile. And 50 is the second quartile, we call the Q2. 50 is also the median. If we go through a little bit further to see when we immutate the missing values is the immutation. That is for the median values. 75 is the third quartile, we call it Q3, and definitely the max is the Q4. With these values, we can calculate the lower and upper limit of IQR. You see, along this code cell right here, 25 quartile is this value, and the 75 quartile is this value for the body mass. And we can have this calculation, and the lower limit for this IQR range, the low is 1700, the upper limit is 6600 something. All this data within this range, they are considered as normal data. And for the outside this, I mean, lower than this value or larger than this one, they are considered as outliers. For this penguin data set, we'll see how many values we have this. We have two, and definitely we know because these are the two EUD values emitted before. Okay, we know these two values, they are outliers in this column. Do we have some values smaller than the 1700? Let's see. No. Okay. Which means that in this dataset, we only have two outliers. That is the value of 7129 for the body mass. And a straightforward is that we remove these two values, and after remove this, we can be there are 1, 2, 3 is missing because we have removed this row, and the 338, 340, 339, the row is missing. We remove this row. Perfect. Then after that, we will see from here, these two abnormal values are removed, and these 2 points are still here because they are not considered as outliers. They are considered as normal values within the IQR range. Okay, after this data handling, we can make sure that in this data set, there's no outliers. There's no missing values, there's no outliers. And yes, very good for maybe ready for the machine learning tasks, but we can have more tasks to do. It is also possible to certify if some data points are outliers using the mean STD method. Mean STD means mean standard deviation method, and we calculate the mean and also the deviation to see the range. Okay, the same. This is the EUD value, but we calculate the mean and dev value to see the reasonable range using this method. Lower limit is 1728. Okay, reasonable. The upper limit is 67. This lower and upper limit are quite close to that value determined from the IQR method. You see that one is 66, this is 67, this is 16 or 17. It's quite close. This means that you can either use IQR method to determine the lower and upper limit, or you can use the mean STD method to determine. Actually, there's no big difference, I should say. We'll check how many outliers right here. 2. We know this. Outliers smaller than this one. No. And then we remove this. But here we just imitate with the mean value so that we can use this feature during the training. And we come to handling categorical variables. In penguins, we have 3 categories. Let's see what is there. Species, island, sex. For species, island, everything is right here. For the sex, there are missing values for some penguins. And so we need to transform these categorical features to numbers if we want to use these features to train the model. Scikit-learn provides 2 methods. One is one-hot encoding, or HE. The other is label encoding to encode these numerical categorical variables to numerical variables. The OHE will turn each category into multiple columns. You can see in this sex feature, we have 3 values: female, male, and none. So when we create, the OHE will create 3 new columns. Each one we represent with female, male, and this. For a small data set or for a feature with limited number of categorical variables, it is okay. This is quite simple and useful, but for a larger data set, for example, or even for if you have a column, let's say country names, we know that country names, we have more than 200 countries, or in this, if we encode this feature, you will get more than 200 columns. This is really a large data set. This is quite difficult to handle. And even more to say that there are lots of zeros in these columns. So to say, we can use label encoding. Maybe see what is going to happen. Straightforward. We just create one column. We encode all the values in this feature to integers from 0 to the number of variables right here. The female is encoded as 0, male is encoded as 1, and the none is encoded as 2. And this time we just use still have one column to store all this information. This will save the memory, and it's quite convenient to use in these machine learning tasks. Actually, besides the one hot and label encoding, we have the other ways. For example, get dummies in pandas. And this is also straightforward. We got 2 columns about the male and female, but for this none, they are treated as 0. So this function will ignore non-values by default and just leave them out right there. This is the full part about this tutorial. I just demo how to run this code right here, and probably can play more. Let's get back to the last part. We scroll down. We have finalized this distributions, categorical features, handling outliers, and I leave this to you. I have done this, but I think I also leave this to you. You can play with the code to imitate some numerical values using mean standard deviation approach. And encoding categorical variables using label encoding. There are also some other encoding methods, ordinary encoding, binary encoding. You can see how to use this method. Okay, finally, we have a small section about feature engineering. So what is feature engineering? Before that, we handled the missing values, both numerical and categorical features. We identify the outliers and remove these outliers right there. Also encode these categorical variables to numbers. All these steps are the fundamental of preparing data for machine learning. From a broad perspective, all these processes fall under the umbrella of feature engineering. So feature engineering is a process to create, to transform, and to select the right features from the raw data to improve the model's performance in machine learning. In a simple word, I think I should say that it's about the transforming raw data to useful information so that a model can understand and also to detect the hidden patterns in the dataset. So a good feature engineering can significantly boost the model's accuracy, and is often more important than choosing a right algorithm. Say that maybe in future, if you have your own project, you will see that the feature engineering will take a lot of time for you to handle the data, especially data polishing, processing, cleaning, transforming. A lot of processes is included in the feature engineering. All right, a short summary of this episode about the data preparation for machine learning. We have the data preparation. We know that the data preparation is critical, and we used this penguin dataset to look at how to get a statistical analysis, and also the visualization. We process the data, the missing data in the penguins dataset. We are handling missing values, outliers, and also encoding. We have emphasized that the importance of feature engineering. This is the main issue for this episode. And tomorrow morning, we are going to discuss two main tasks about the supervised learning, that is classification and regression.